Hello everyone. Today we're continuing working through the 2022 November Physical Sciences paper 2. This is grade 12. So this is question 2. Question 1 has been done in a previous video. That's the multiple choice section. Today we'll be working through the next question. Alright, so let's get straight to it. A to F in the table below represents 6 organic compounds. Okay, so maybe before we get to the actual questions, we can just go through these compounds real quick. So what we have with compound A, we have this chain here. That's the longest chain through the compound. So this is some sort of pentane molecule with a halogen atom, so some sort of haloalkane, but it also has this ethyl group and this methyl group. So interesting compound. B is a bit different. B, the longest chain through the molecule is here. So again, some pent molecule, but we have a triple bond. So that's like pentyne. And then we have a methyl group, another methyl group. Yeah. So 2 methyl groups on the pentyne molecule. Okay. Here, molecule compound C, we have some sort of ketone. Oh no, not a ketone. This is a aldehyde, because the carbonyl group is at the end of the molecule, not in the middle. So that makes it an aldehyde. Here we have a ketone because the carbonyl group is in the middle of the molecule. Here we have a carboxylic acid, and here we have an alcohol. Okay, so some different compounds. All right, let's get into the questions. Write down the letters that represent 2 organic compounds that are isomers of each other. Well, isomers definitely all have the same amount of atoms. Okay, so I mean, we can just check. So A has how many carbons? 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons and a bromine. And the thing is, there's nothing else here that has a bromine. So A isn't an isomer with anything. How many carbons do we have here? But now, you see, the problem is molecule B only has carbon and hydrogen, only carbons and hydrogens. The other molecules have carbons, hydrogens, and oxygens. So B is not an isomer with anything. Okay, let's have a look at C. So C has 1, 2, 3, 4 carbons. D also has 4, so that's a good start. F also has 4. And now E has got 2 oxygens. There's an oxygen here and oxygen here, and no other molecule has any oxygens. So that's not an isomer with anything. So it's between C, D, and F. Okay. Now, let's count the hydrogens maybe to see how many hydrogens each molecule has. So here in molecule F, we have 3, 5, 7, plus 3 again. So we have 10 hydrogens. In D, we have 3, 6, 8. We only have 8. Oh, okay. What about C? 3, 5, 6, 7, 8. We also have 8. So F cannot be an isomer with anything because it has more hydrogens than D and C. Therefore, the isomers are definitely C and D. So for 211, 2.1.1, it's C and D. Okay. Let me just clean up my work here. Okay. Moving on. Type of isomers, chain, functional, positional, identified in question 2.1.1. Okay. So these isomers are not functional. I mean, let's see. How are these isomers related? What do they have in common? The thing is, they both have this carbonyl group, okay? The C double bond O. And that serves as the functional group. So the only difference is the positioning of the functional group. They both are straight chain molecules. There's no branching, so they're not chain isomers. And positional isomers are a bit different. They're pretty similar to functional isomers, but in this case, it is the functional group, the position of the functional group that is different. So more correctly, I guess positional isomer is correct as well, but more correctly, since it is the functional group that's changed position, we would call these functional isomers. So these are functional isomers. Um, 2.1.3, the general formula of the homologous series to which compound B belongs to. Okay, this is a tricky one. If you're not sure, like you haven't memorized these, we can just go through them real quick. So the first is alkanes. Okay, alkanes, which are saturated molecules, have the general formula CnH2n plus 2. Okay, and that makes sense. So if we have, let's say, a 3-carbon molecule, so N equals 3, right? If we just imagine N equals 3, it tells us how many hydrogens there should be. So 2 times 3 is 6 plus 2 is 8. So 1, 2, 3, 4, 5, 6, 7, 8. Makes sense. Okay. So what about alkenes, right? The next level up. Alkenes follow this formula. So we have some double bond. Let's say 3 again. So that tells us that we should have 6 hydrogens. So 1, 2, 3, 4, 5, 6. Because a carbon can only have 4 bonds. So that makes sense as well. So now, B is an alkyne, right? So what's the next level up? So imagine if we had some molecule and it has a triple bond, right? Triple bond. How many hydrogens can we fit here? 1, 2, 3, 4 only. Yeah, we can only fit 4. So Cn and then H, what would the H part be if we can only fit 4 and we have we can only fit 4 hydrogens and we have 3 carbons? Well, it looks something like this. And if we do the math to say 2 and we have our 3 carbons minus 2, 6 minus 2 equals 4, which is the 4 we fit here, 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 and here. Okay, so this is the formula. Yeah, it's a bit difficult to work these out if you haven't memorized them, so it's a good thing to just consider just knowing them by head, the 3 different formulas for an alkane, an alkene, and an alkyne. Okay, moving on. Name the functional group of compound F. Okay, so it is an alcohol, but I don't think you'd be marked down for saying alcohol, but it might be more accurate to just say hydroxyl. Hydroxyl group. Alcohol group is a bit vague. Hydroxyl group is a bit more specific. Hydroxyl just refers to the OH, yeah, similar to hydroxide, you know, like from something like this. But hydroxyl, not wrong. Okay, so hydroxyl group. Continuing with 2.2, okay. We're going to be naming some compounds. Write down the IUPAC name of compound A. Okay. So first of all, let's figure out which is the longest chain in our molecule. And the longest chain runs here. Okay. And we have how many? 1, 2, 3, 4, 5. Actually, no, that isn't the longest chain. The longest chain is actually this one. Which is actually 6 carbons. So hexane is our root molecule. So why don't we just write hexane down somewhere? Okay. And then what else do we have on this molecule? Well, we have a bromine atom on 1, 2, 3, 4, 1, 2, 3. So 1, 2, 3. So what we're going to do is we're going to assign our carbons this way. 1, 2, 3, 4, 5, 6. And the reason we're going to do it that way is because we have 2 additional groups this side. So it makes sense to start counting here. If we start counting from here, there's only 1 group here first. So we'll prioritize counting from the left. Okay. It's getting a bit messy. So we're going to go 1, 2, 3, 4, 5, 6. Okay, so we have these 2 methyl groups on our 3rd carbon. Okay, so we definitely know that we have 3 dimethyl somewhere in our molecule. Okay, and then on our 4th carbon here, we have 4 bromo. Okay, bromo for bromine. Now, putting this all together, actually, since there's 2 methyl groups, we have to write 3 twice. So let's put it all together. So the thing is, what we do is we put it together in alphabetical order. So B before M, and then hexane is our stem. So hexane will go last. So that gives us 4 bromo, 3 dimethyl hexane. And some people write this as 1 word, some people write this as 2. I think it's really up to you. You can write this as 1 word, dimethyl hexane. And that's how we'll name compound A. Okay, compound B. Okay, so if we count this way, we have 5. If we count this way, we also have 5. I guess it doesn't matter, because whether we count this way or this way, either way we still have 2 methyls or 2 methyls both ways. So it doesn't matter which way we count. So here our stem is pentyne, like this. And if we want to be specific to just let us know where the triple bond is, we can, well, whichever way you count, it's on the 2nd carbon. So we can write it as pent to yne, as just to indicate where the 2nd carbon, where the double bond is. And in this case, because we have a distinct functional group in the chain, So we'll prioritize this functional group over the 2 methyls, okay? So we're gonna start counting from right to left. So we'll say 1, 2, 3, 4, 5. That means our 2 methyl groups are on the 4th carbon. So we're gonna have 4, 4 dimethyl once again. Putting that all together. So alphabetical order. Well, this is the stem, it has to go last, and this is before. So we have 4, 4 dimethyl pent 2 iron. Okay. And that's the name of compound B. Okay. So let's have a look at compound C next. Okay. Compound C. Okay. So compound C. Okay, we have 4 carbons. So we know that our compound starts with but, 4, and it's an aldehyde. So we know that aldehydes end in NAL. Yeah, and since it's terminal, I mean, you can, if you really want to, you can say 1-butanol, but you don't have to. You don't have to include this one. It's not entirely necessary, but technically that would be absolutely correct as well. But by just saying butanol, it is implied that the functional group is terminal. And anyways, in aldehydes, the functional group is always at the end. It's always at the terminal end of the chain. So you don't have to say 1-butanol, but if you did, it would still be fine. Okay. 2.3. Compound F reacts with a carboxylic acid to form compound S in the presence of a strong acid. Write down the type of reaction that takes place. Okay. So we have an alcohol reacting with... Ooh, okay, compound S is unknown. Oh, they tell us carboxylic acid. It is esterification, because we're going, so an alcohol plus carboxylic acid. This is going to give us an ester. Okay, so we know that our reaction is an esterification reaction or a condensation reaction. That is also acceptable. You can say that as well, but more correctly, more specifically, esterification reaction. Okay. Okay, 2.3.2. Write down the molecular formula of the carboxylic acid. Okay. So they give us some information about compound S. So compound F is CH3, CH2, 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 OH. Compound S, C3H6O. We know it's a carboxylic acid, so we know that at the end we have... okay. Oh, the ester, right? So we know that... Wait, I'm getting my wires crossed. So this is plus the carboxylic acid. Okay. Carboxylic acid. And then this is going to give us C3H6O, which we know is an ester. So the ester has the general form, some molecule here, O, and some other carbon chain here. So, okay. Is this right? Okay. But this is not the full formula. This is just the empirical formula. So we can't do much until we first figure out the full formula of the molecule. Okay. So we need to figure out the full formula. So its molecular mass is 116 grams per mole. Okay. What is the molecular mass of the empirical formula? So we have 3 carbons. So we can say the molecular mass of 3 carbons, 6 hydrogens, and 1 oxygen. You can calculate that quickly, but it's about 58 grams per mole. So here we're going to get a ratio of about 2. So we need to multiply everything in this molecule by 2. Okay, so we'll actually get something like C6, H12, O2. Okay. Oh, and what I had drawn here is actually wrong. That's not an ester. That's a ketone. So it's supposed to be O. So it's supposed to be O and then the second group. Okay. All right. So have we answered the question? The molecular formula of the carboxylic acid. Okay. So, I mean, you can try and figure out exactly what the molecules look like, but you don't have to. So we can just subtract our 2 molecules here. So here we have 1, 2, 3, 4, right? So 4. And here we have 3, 5, 7, 9, 10, and 1. So the molecular formula of our carboxylic acid, when we subtract here, will be C2H2O. Did I do that correctly? Oh, but we lose water as well, right? So it's important that there is water lost, in the reaction. I guess this is the tricky part, is realizing this is why I said it's an esterification or a condensation reaction, because you can also lose water. So we need to add that back to our carboxylic acid. So we have C2H4O2. Okay. All right, and now we answered the question. Okay, so 2.3.2, it is C2H4O2. Okay, done.